Hey guys, welcome back to AlgoYogi. We are doing two pointers series. Our next problem in the list is valid palindrome. Now we have done a lot of these problems. So palindrome, isomorphic, anagrams, these are the terms that we are already familiar. So we're not gonna go deep into, just go over the definition again and again because we already know. So if you don't, please look up. So in this problem, we got to find out if it's a valid palindrome, and the way they have defined it for this particular problem is a phrase is a palindrome if after converting all uppercase letters into lowercase letters and removing all non-alphanumeric characters. So what are non-alphanumeric characters? Anything and everything that's not a number, that's not a digit. So those are alphanumeric characters, non-alphanumeric characters. So it reads the same forward and backward. So basically palindrome definition is just we gotta only check for the alphanumeric characters given to us in this string S. All right, so return true or false depending on if it is palindrome or not. So S is given to us like this. It's a basically like a string, but it might contain these non-alphanumeric characters, which is this colon, this comma, even like this space, white space. They're all non-alphanumeric. So we gotta ignore them. So if they are there, then we ignore it and move forward. And so basically, let's see what they're actually asking us. So this is our first example, and we're going to check if it is a valid palindrome given we get rid of all the non-alphanumeric characters and we convert everything to basically lowercase. So if we do that, then it's going to become A, removing the space. This space is removed. Then MANAPLAN, and you can see like this is basically this is where the plan ends. This is where this is man A. I'm converting them into smaller case and also removing non-alphanumeric values. And then, oh my god, I gotta change. Yeah, and then ACANALPANAMA. Now this value we have to check if it is a palindrome, and you know what it is. How are we gonna check it? Two pointers approach. So we're gonna have a pointer right in the front, right in the back, and we're gonna keep checking. So the start will move forward, end will move backward, and wherever we come across where these values are basically not matching, we return false. If S start does not match and S end, we return false. Okay, otherwise we return true. But this alphanumeric thing, we're gonna handle it in our basically in our while loop of two pointers. All right, then let's go and code our solution. It's going to be a big of n time complexity solution, and we are trying to do it in place, so we're not gonna store anything, right? It's not like I'm gonna convert it to this value. This value you're seeing over here, so I'm not going to do that. I'll do it in just one go, okay, one pass. I'm not going to convert this first and then do it. We'll do it in one pass. So but so far, like, you know, we have learned how to do that. Okay, let's code it up, our solution. So first thing first, we're going to have our pointers start and end, start and end. Start starts at 0 and is going to be len of S, you know. And let's convert S to lowercase already. Okay, so I'm just gonna convert it to lower Okay, that's how you do it. Now I'm gonna start my while loop for while start is lesser than end. And so there are a few things. In order to ignore these alphanumeric values, and so that our start and end pointers are only checking the values which are alphanumeric. So, and if it is a non-alphanumeric, we gotta just continue and ignore that. So let's have that check first. So if s start basically dot is num. I think this is the function to check, so we can check it later if it is not, right? I think this is what I recall. So if this is not alpha num, then we gotta decrement our end pointer and continue basically to whatever this value matches with the front. And we're gonna do the same thing with the start. Yeah, sorry, oh my god. I'm checking for start and doing it for end, so that was bad. Okay, so start is done and end is decremented and we continue. Okay, start is done, end is done. Now is the real thing. What is it? If now these valid values are with me right now, okay, these valid values are with me right now. So now what I'll do is s start, if s start is not equal to s end, then I return false. Okay, otherwise I return true. But most importantly, what we want to do here is start increments and end decrements by 1. Okay, looks pretty good to me. Okay, so you know what, let's have some gap. Makes the code looks cleaner that way. Okay, so let's zoom out. Let's run it on our examples and see if we're missing anything. Alnum might give us a problem, but I'm hopeful it should not. Yes, it did, and that's because our string index out of bound, and that is stupid mistake over here, because index always start at 0, so we always should decrement our length by 1 if we are trying to access it, you know, the last index. All right, then it's accepted, like with the problems. Oh my god. Okay, now let's write the time complexity. Oh my god, was for because I'm feeling tired. Okay, it's just Sunday, beautiful Sunday, and I did a 5-mile run before I started recording these videos, and I'm feeling pretty tired. Yeah, sorry, I'm doing my Randi Rona here. Okay, big off, but big off n, because we are going through each element, although we are ignoring some, but we are going through everything. Space complexity is big of 1 because we are not using any extra space. We are just playing around with the pointers. Okay, awesome. Let's go to AlgoYogi, mark this solved. See you guys in the next problem. Until then, bye bye, namaste, sat shri akal. Do it. हिंदी बोलता हूँ मैं भाई, मैं मजाक कर रहा हूँ ये चलो